Hello everyone, this is Moshami and today I am here with some problems on motion in a plane. So let's look at the first one. This has appeared in JEE Advanced in the year 2022. A projectile is fired from horizontal ground with speed v and projection angle theta. When the acceleration due to gravity is g, the range of the projectile is d. If at the highest point in its trajectory, the projectile enters a different region where the effective acceleration due to gravity is g dash, which is given by g by 0.81, then the new range is d dash, which is equal to nd. The value of n is. So let's explore the case. We have a projectile that has been fired from the ground with a speed v at a projection angle of theta. Now the acceleration due to gravity was g and the range of the projectile is d. So let us write an expression for the range of the projectile. Let me represent range as r. Okay, the range has been given as d. We shall use accordingly. D, which is equal to, the speed is v. So the formula for range was u square sine 2 theta by g. We have v coming up here, v square sine 2 theta by g. G is the acceleration due to gravity and theta is the projection angle. Now if this is the case, the maximum height attained by the projectile, the maximum height attained. The formula for the maximum height is given as h equal v square sine square theta by 2g. Now at the highest point, the projectile enters a different region where the acceleration due to gravity is not g but given as g dash, which is equal to g by 0.81. So at the highest point, now till the projectile has reached the highest point, it was travelling with a certain speed as we have seen, and it was travelling with that speed and it reached the highest point, and then from there at the highest point it enters a different region. So let us find out the time which is taken by the projectile once it enters the different region to reach the ground. At the highest point, the time taken by the projectile to reach ground in the new region. That is, it has entered the new region and then the time taken by it to reach the ground will be given as t, which is equal to root over twice h by g dash, because within the new region the acceleration due to gravity is not g but given by g dash, which is equal to g by 0.81. Now let's substitute the value here. We have t equals, this is root over 2h. h is given as v square sine square theta by 2g, and here we have g dash, which is nothing but g by 0.81. So the factor 0.81 comes in the numerator. So we have t equals, just have a look at this. We have v square root over v square sine square theta by g square times 0.81. So 0.81 is nothing but 0.9 whole square. So taking the whole thing outside the root, what we have is 0.9 v sine theta by g. So this is the time taken by the projectile after it has entered the new region to reach the ground. Till before that, it was travelling with a certain speed But after entering the new region, the time taken by the projectile to reach the ground is given by this. Now what we need to find out here in fact, is the new range. Now, if this is the time taken, what do we write how do we write an expression for the displacement? Range is nothing but the displacement from the starting position. So, the horizontal displacement, we can write this, the horizontal displacement of the projectile it is given as v cos theta times the time. This is the horizontal displacement and it is taking place in a time t. So, this is the horizontal displacement of the projectile. We can find this out. Let's do this. Let's solve this here. We have this is v cos theta times the time. Time is nothing but 0.9 v sin theta by g. So just have a look at this. We have 0.9 v square sin theta cos theta by g. So if you take a look at this, we have v squared. This is, if we try to bring in the multiple angle concept, that is sin 2 theta, which is equal to 2 sin theta cos theta. So using this, we have sin theta cos theta is nothing but sin 2 theta by 2. So we may write this here. This is 0.9 v square by g, and sin theta cos theta is nothing but sin 2 theta by 2. So you can write this in this way. So ultimately what we have here is 0.9 by 2, and we have v squared sin 2 theta by g. So if you take a note, v square sin 2 theta by g is nothing but the range d. So this is in fact 0.45 d. So this is the horizontal displacement of the projectile. Now we need to find out the new range. This is the displacement from the highest point. Until before that, the displacement was, if you imagine this, if this is the case of the projectile fired at a certain angle, this is the thing that is happening. This total distance, the total range would have been d. So at the highest point, the distance covered would be equal to d by 2. So here that we need to understand is, how do we find out the new range? New range is nothing but the distance taken by the projectile to first reach the highest point, the distance covered. As we can see, the distance covered is equal to d by 2. This is only till it reaches the highest point, and after that the horizontal displacement that it covered was nothing but, we find it out to be 0.45 d. So a sum of the two. Let me give this as x, the horizontal displacement. If this would have been equal to x, then this is nothing but d by 2 plus x, and then we have this d by 2 plus this is 0.45 d. So ultimately this is 0.5 d plus 0.45 d or 0.95 d. So we see that the new range d dash becomes equal to 0.95 times d. So comparing this with this particular relation, we may write that n is nothing but equal to 0.95. So wonderful problem. Now let's have a look at the next problem. a projectile is thrown from a point O on the ground at an angle 45 degree with speed 5 root 2 meter per second. The projectile at the highest point of its projectile trajectory splits into two equal parts. One part falls vertically down to the ground 0.5 seconds after the splitting. The other part t seconds after the splitting falls to the ground at a distance x meters from the point O. The acceleration due to gravity g equals 10 meter per second square. The values of t and x are. So again, a wonderful problem on projectiles. A projectile has been thrown from a point O on the ground at an angle 45 degree with speed 5 root 2 meter per second. Let's visualize this diagrammatically. So this is the point O from which the projectile has been projected with a speed of u equals 5 root 2 meter per second. The angle of projection is 45 degree. So this suggests that for any point on the trajectory, the components of u, that is ux and uy, they are both equal to 5 meter per second. So this is by the process of addition of vectors. U square will be equal to ux square plus uy square. So that will give us ux and ux square plus uy square as equal to u square, that is 5 root 2 whole square. So we get that the sum of the two is equal to 5 square, or each is equal to 5 meter per second. Now the range of the projectile, range is the distance traversed from the point of projection. Let me assume the range to be r. So the range of the projectile, let's go with the formula for range. R equals u square sine 2 theta by g. So we have theta equals 45 degree. So this will give us range as equal to u square, that is 5 root 2 whole square, sine 2 theta, that is sine 90 degree by 10. Sine 90 is equal to 1. We have here 25 times root 2 square, which is 2 by 10. So this is equal to 5 meters. So we see that the range of the projectile is equal to 5 meters. Now the time of flight. T will be equal to twice u sine theta by g. So this is 2 times u, that is 5 root 2, sine 45, which is 1 by root 2, and g, that's 10. So we get this as, you can see, this is equal to 1 second. So this is the time of flight. Now, when the projectile is at the highest point, it splits up into two parts of equal masses. So one part is falling vertically down. So let us assume this part to be of mass m, and the other part is moving with a certain speed, say v, and then after some time it falls to the ground. So this is what is happening here. Now just note, till the time the splitting was not there, till the time the projectile was moving along this particular path till it reached the highest point, let us assume that the net mass of the projectile was 2m and it was moving with a speed of 5 root 2 meter per second, and by the time it reached the highest point, it had covered a distance, horizontal distance, as equal to r by 2. As you can see, the net range would have been r, so half of it till the highest point, that's equal to r by 2. So till this much, the displacement is equal to r by 2, or the distance covered from the starting position is equal to r by 2. Now at this point the splitting takes part. So after splitting, what is happening is that only the second part, which has got a mass m, that is moving with a certain velocity and striking the ground after some time. So let us first find out the time which is taken by the second part to reach the ground. Before that, the time taken by the first part of course means the part of the projectile after splitting. First part to reach ground. This has been given. This time is equal to 0.5 seconds. So this tells us, since the time of flight was 1 second, so the time taken by the second part to reach the ground will be equal to, again, 0.5 seconds. Hope you get this. The total time of flight was 1 second. That for the first particle or the first part of the projectile was 0.5 seconds. So for the second part also it's equal to 0.5 seconds. Now for the second part, which is assumed to be moving with a velocity v, how do we find out that velocity v? For that we apply the principle of conservation of momentum. Now when we are talking of this principle, we are here actually considering the vertical motion. So we are to consider the components of speed or velocity which are in the vertical directions only. So for that, before splitting, the net mass of the projectile was 2m and the speed was equal to 5, since we are talking of the vertical component of the speed only. So this is the speed here, and after splitting we had only the second part moving with the speed b. The first part had fallen vertically downwards, so it was under the action of gravity. So only for the second part we have its mass as m and the speed as equal to v. So we get from here that v will be equal to 10 meter per second. Now from this we come to know that we can easily find out the displacement of the second part in the horizontal direction. So displacement of the second part in the horizontal direction Now take note, displacement of the second part in the horizontal direction is nothing but we are considering traversing some distance, this much. From the highest point we had the origin of the second part. So from the highest point till how much distance is covering, we are trying to look at that. So this displacement will be nothing but equal to its speed, the speed of the second part, multiplied by the time taken by the second part to reach the ground. Let us assume this time to be little t. So we have this. So v is 10 and t is 0.5. So the displacement will be 5 meters. So if you notice 5 meter, that is, this was nothing but the range of the projectile. So this distance actually, which is covered by the second part from the highest point in touching the ground, this distance covered is nothing but equal to again r, the range. So we were asked to find out the value of x, and what was x? X was the distance travelled by the second part from the point O. So let's work that out. So distance travelled, in fact the net distance covered by the second part from the point O is nothing but equal to this distance r by 2 up till the highest point plus the displacement of the second part in the horizontal direction, which amounts to r. So we have this as 3 by 2 r, that's equal to 3 by 2 times r, which is 5 meters. So we see that this is equal to 7.5 meters. So we see that the values of t and x, this distance is nothing but x that they are sorting in the question. So we have the values of t as equal to 0.5 seconds and the value of x as equal to 7.5 meters. So we have many more sums in store for you. Keep following at JEE. Thank you.